Welcome back, and today's video is about kinematics. So this features in most calculus courses. If you're doing AP, it's Unit 4. If you're doing IB, it's the AA course, standard level and higher level. Also features in A level. So it's a connection between displacement, velocity, and acceleration, and we need to use differential calculus in order to move between those different formats. So we differentiate, we move one way, and if we integrate, we move another. In this video, I will give you the brief theory behind all of the kinematics and also go through an exam style question so you can see it all put into action. Let's dive in.
No way. No way. Yes way!
Okay, so let's start by looking at some of these terms. So displacement means the distance away from a given point. This is usually the origin. So that displacement will be represented by s of t, so a function of t, and we use the letter s for displacement. Velocity will be defined as v of t, so a function of t again, but this time velocity, and acceleration will be a of t. Right, now that's SVA, but in some courses what they may say is if you start off with s of t as displacement, then the velocity will be s prime of t. That is because you have to differentiate displacement with respect to time, so you differentiate with respect to time, and you will end up with velocity. So these things are exactly the same. And if we differentiate with respect to time again, then you may end up with this expression, s double prime of t. So it's just important to note before we even start that in some questions, you may see velocity written as s prime of t and s double prime of t for acceleration.
Boy, that escalated quickly. I mean, that really got out of hand fast.
It jumped up a notch.
It did, didn't it?
The systems that you'll encounter are generally like all in one direction. So that's why it's called motion in a straight line in some courses. So we're either going to be working horizontally or we're going to be working vertically. Now, it's important to note what happens if we're working horizontally. Well, consider the origin here at the center. If we are to the right, let's just put our particle here on the right. We are on the right of the zero. So that is just a positive displacement. Now, the direction of the particle, which way it's moving, is also important. So if it's moving to the right, that is a positive velocity. If the particle moves to the left, that is a negative velocity. So that depends on this sort of horizontal direction that you're moving. Vertically, if you are, let's say, below, let's put the particle this time down below zero, therefore then that is a negative displacement. Then up would be positive velocity and down would be negative velocity. If you differentiate displacement, we get velocity. If you differentiate again, we get acceleration. And to go back the other way, we would have to integrate acceleration to get velocity and integrate velocity to get displacement. So we haven't seen a function yet, and that's what we're going to do in one of the examples. There is one more thing I want to cover, and that is through integration, we can find the change of displacement of the particle between two time frames or the total distance traveled by the particle. So over here, I have a velocity time graph. And let's say we want to know the distance that something covers in a certain time frame. So let's say, imagine a ball or a particle moving, and between two time frames, it's traveled some distance. So the total distance that is traveled between two time frames would be found by doing the integral of vt, and this will be modulus, okay, between time frame 1 and time frame 2. So in the example that I'm going to do, I'm actually going to cover this. If you just want to know the simple change of displacement, we don't need the modulus sign. So that would mean then, let's say a particle starts at one place, moves away, and comes back and finishes at the same place. The change in displacement there is actually zero, but it has traveled some distance away and back. So this change in displacement is very different to total distance traveled. Okay, so let's move on to this example where we're going to cover all of those things throughout this question, starting with, suppose a particle's displacement is modeled by the following expression. So this is a displacement expression here, and it says find the expression for velocity and acceleration. So what I'll do is, based on the grid that I just showed you, if we differentiate this now, we will get velocity. So differentiating that would give us s prime of t. Don't forget that that then is the velocity. So differentiating that is just going to be using power rule. So we're going to multiply by the power and then take one off. So that will be 3t squared minus 12t plus 9, and that is the velocity. Acceleration means that we would need to differentiate it again, so that would be s double prime of t. That would be the acceleration, and we're going to differentiate this, so we're going to end up with 6t minus 12, and that is an expression for acceleration. What are the initial conditions of the particle? So when we're ever asked for initial conditions, that just means that time is 0. So when you plug 0 into this expression, that will give us all of the initial conditions. So what I'll do is I'll just do it one by one. Okay, so when we substitute 0 into the displacement, we will get 0 minus 0 plus 0 minus 1. Okay, so the initial displacement of the particle is minus 1, and if you look very carefully, it's centimeters, so it's minus 1 centimeters. So therefore, then, it is to the left of the origin. When we substitute 0 into velocity, so it's basically v of 0, we would get, okay, 0 minus 0 plus 9. So the initial velocity, v of 0, will be 9, and it's in centimeters and seconds. So it's centimeters per second. So sometimes people write centimeters per second like this, or it might be centimeters per second written in index form, positive. So that means it is moving to the right. Acceleration, so that means we're going to be plugging 0 in for acceleration. So we will get 0 minus 12. So the initial acceleration will be minus 12 centimeters per second squared, or sometimes centimeters per second. Right? That means that the particle is slowing down. If it is negative, it is decelerating. Find the position where the direction changes. Now, when a direction changes, imagine a particle moving along and then turns around. At that point, when it turns around, the velocity is equal to 0 because there's an instantaneous point that the particle is not moving. So in other words, we want to know when is the velocity equal to 0. So if we just go back and get our velocity function, and that was this one here, we want to know when this expression is equal to 0. So it's actually a quadratic that we need to solve because we want to know when the right-hand side, when is this equal to 0. So we're going to set it up equal to 0 here. So it's 3t squared minus 12t plus 9. I can see that a factor of 3 can come out of everything here. So that will be 3, open brackets, t squared minus 4t plus 3. Okay, so we need to factorize this up. Let's go 0 equals 3. And now it's minus 4 and plus 3, so that'll be t minus 1 and t minus 3. Factorize. Therefore, that this expression will be 0 when either t is equal to 1 or t is equal to 3. So the particle will be changing direction at those points because the velocity is equal to 0 at those points. And as I stated above, when the velocity is equal to 0, that is when we have a turning point, because the particle has changed from either a positive to a negative or a negative to a positive. Okay, part D of the question is asking us to find the total distance traveled in the first 3 seconds of motion. But the total distance traveled is dictated by this formula. So we have here distance between 2 time frames can be found by doing the integral of the absolute value of v, right, with respect to t. Basically, what you're doing is you're finding the area beneath the graph on a velocity time graph. And I could just use my calculator to do this. So if you're doing an AP course, you have access to a graphical calculator. If you're doing the IB, that is the same. I'll just jump over to my calculator now and we'll plug this in. The expression for v, this is the velocity, so that will go into this expression here. And so what the times are is it says what is the total distance traveled in the first 3 seconds? So that means that we need to move from time 0, okay, to time 3, because it says first 3 seconds. So our limits on our integral will be 0 to 3. Okay, so here is the calculator, and I'm just going to bring up this operation here next to the number 9. So we can click this, and then we can do integral. So the integral that we're looking for is this one here. We're going to just type that in, and our limits, I said, with a time frame. So it was 0 to 3. And then we want to put the absolute value. That's quite important here. So that option is also under this sort of operation here. And we are looking for the modulus, or the absolute value. So we put this down. And then we have our expression for velocity, which was 3t squared minus 12t minus 12t and plus 9 plus 9. Now you can use x, but just make sure whatever you use that you put the corresponding variable here at the end. So we're integrating with respect to t. Press enter, and it is 8. So we're saying that the total distance traveled is 8 centimeters. So if we just jump back over to the question here, we are getting a value of 8 centimeters using the graphical calculator. And that is the end of the question. So, kinematic problems, do you find them easy or difficult? Would you like me to go through more past exam questions? Don't forget to hit subscribe, smash the like button, let me know in the comments below what your thoughts are. I'll see you next time.